Hello and welcome to another lecture on differentiation. Today we shall be discussing about differentiation of logarithmic and exponential functions. Later we are going to discuss the method of logarithmic differentiation, and finally we shall conclude by discussing some numerical problems that would be based on logarithmic and exponential differentiation. Before discussing about logarithmic and exponential differentiation, first let us consider the following results that are based on logarithmic and exponential functions. The first result gives us the value of logarithmic with base a m into n equal to log m with base a plus log n with base a. Next we have the value of logarithmic with base a m by n, which is equal to log m with base a minus log n with base a. Next we have the logarithm of m to power n with base a, which is equal to n log m with base a. Next we have that log of m with base a can be rewritten as log of m with base b into log of b with base b, or log of m with base b can be written as log m with base a divided by log of b with base a. The log of 1 with base a is always equal to 0. The value of log of a with base a is equal to 1. The value of 1 plus x to power 1 by x with limit x tending to 0 is equal to e. The function e to power x minus 1 divided by x with limit x tending to 0 is equal to 1. The function ax minus 1 divided by x with limit x tending to 0 is equal to log of a with base e. Now here, if no base is mentioned, then it will be understood that the base is e. Next we are going to discuss the differentiation of logarithmic function. First let us find the value of the derivative of x with base a, that is d by dx of log x with base a. This is equal to 1 by x log a with base e. Next we are going to find the value of the derivative of log x with base e, that is d by dx of log x with base e, which is equal to 1 by x. Next we are going to discuss the differentiation of exponential functions. For that, let us first consider the derivative of e with power fx, where fx is a function of x, that is d by dx of e to power fx, which is equal to e to power fx into derivative of fx with respect to x. Next we have to find the value of the derivative of a to power x, that is d by dx of a to power x, which is equal to ax into log of a with base e. Next we are going to discuss the logarithmic differentiation, which is the process of taking logarithms before differentiation. It is useful in differentiating functions of the type u with power v, that is a function with the power of a function, or uv or u by v, where u and v are both functions of x. Now this would be more clear by considering an example. So for example, we consider a function which is given as y equal to x plus 2 divided by x minus 1 into x plus 5. Next we take logarithm of both sides and we get log of y equal to log of x plus 2 minus log of x minus 1 minus log of x plus 5. Now differentiating both sides with respect to x, we get 1 by y dy by dx equal to 1 divided by x plus 2 minus 1 divided by x minus 1 minus 1 divided by x plus 5. Therefore, we can write dy by dx equal to 1 divided by x plus 2 minus 1 divided by x minus 1 minus 1 divided by x plus 5 whole multiplied by y, which is equal to x plus 2 divided by x minus 1 into x plus 5. Thus, by the use of logarithmic differentiation, we have differentiated the given expression, which was of the form u by v, and thus solved the given expression in the required form. Next, we are going to discuss a problem that is based on the differentiation of a logarithmic function. Now here we have a problem in which we are required to differentiate with respect to x the given function, which is log of root of 1 minus cos x whole divided by 1 plus cos x. Here let us consider y equal to log of root of 1 minus cos x divided by 1 plus cos x, which is the term that is to be differentiated. Now we can write this value of y in terms of sine x by 2 as log of root of 2 sine square x by 2 divided by 2 cos square x by 2. Now this can be simplified as log of 10 x by 2. Thus now we have y equal to log of 10 x by 2, and in order to differentiate log of root 1 minus cos x whole divided by 1 plus cos x, we need to differentiate log of 10x by 2, that is d by dx of log 10x by 2, which is equal to 1 divided by 10x by 2 into differentiation of 10x by 2 with respect to x, which gives us 1 divided by 10x by 2 into 1 by 2 sec square x by 2, which can be rewritten in terms of cos and sine as cos x by 2 divided by sine x by 2 into 1 by 2 sec square x by 2 can be written as 1 divided by cos square x by 2. This gives us 1 divided by 2 sine x by 2 into cos x by 2, which is equal to 1 by sine x. And since 1 by sine x is equal to cosec x, therefore differentiating the term log root of 1 minus cos x divided by 1 plus cos x gives us cosec x as the result. We have another problem in which we are required to differentiate an exponential function of the type e to power 10 ax, that is d by dx of e to power 10 ax is to be found. Now we know that any exponential function of the type e to power fx can be differentiated as e to power fx into d by dx of fx, and thus we can write the differentiation of this exponential function as e to power 10 ax into d by dx of 10 ax. This is equal to e to power 10 ax into sec square ax into d by dx of ax, which is equal to e 10 ax into sec square ax into a, which can be rewritten as a sec square ax into e to power 10 ax. With this we conclude this lecture on differentiation, which was based on logarithmic and exponential differentiation.